again to electromagnetism, electrostatic fields. Today we are with applications to Coulomb's law, basically discussion about the electric field. This is our learning map. Last time we discussed about the Coulomb's law and the electric force. Now we are translating this force to electric field. First thing we will discuss electric field due to a point charge. The electric field is defined as the electric force due to some charge Q1 here over a unity charge QT. This means that if we divide Q the force over the charge, that is the charge, we will get our electric field. Here, if we remind ourselves, we have Coulomb law state that the force is equal to Q1 QT, the two charges, divided by 4 by epsilon naught R magnitude R squared, where R can be calculated as shown here. And finally, our field will look like this. This is the final equation which we are seeking for the point charge. And the unit for this one is Newton per Coulomb because we are dividing here force over charge. And also we will understand later that this also volt per meter, and this actually more commonly used units. So let's have some example. We are being told that we have two charges, Q1 and Q2, located at minus A in the x-axis and A in the x-axis also, because other are zero. And we are being asked that where is the point that satisfies this condition, which is the electric field is equal to zero. So from the points which we have here, we can understand that this will occur in the x-axis. Why? Because both charges are located in the x-axis. So at some point x naught 0 and 0, there will be our equal to 0. So let's solve directly, and later we will have some note. So to solve, we need to calculate R for both units. So we'll say R1 due to the first point here. This is R1. And we have R2 due to the second point, this one. So as we have learned before, just subtract the 2 points from each other, the point which we are calculating for here, and the point which we are starting with. So simply you will get this result. And for R2 the same, but here you will get x naught minus a, and we can rewrite this one in terms of vectors. So we have R1 is just in the x direction, x naught plus a in the I direction, and R2 is x naught minus a in the I direction also. And we can calculate also the magnitude here, because magnitude is just square of every sum of everything. The three we have here two zeros, and we have only x component, with that's why the magnitude will cancel, sorry, the square root will cancel with the square. And finally the direction also will be just a1 and a2 equal to I, because both of them are assumed to be positive. So from the first step we got these values, and just to remind ourselves, we have E equal just to the charge divided by 2 by epsilon naught, some vector R in the direction of A. And if we substitute here, this square, if we substitute here, we have the first charge is Q, the second charge is minus 2Q, and this is what we calculate R1 here, and this is R2. So we just substitute with these values, and then we apply the condition. So the condition is E equal to 0, so we'll make summation of these two guys here, and then we will get that this condition to be satisfied, this equation should be equal to 0, because I cannot be equal to 0. So we go and make mathematical manipulation. So what will happen here, Q will go with Q 4 by epsilon naught, and this is also 4 by epsilon naught will cancel with 4 by epsilon naught, and you will be left with a condition which contain x naught and a only, and just mathematical manipulation after that. So just move this one to the other side, you will get this equation here. make cross multiplication. So you will get 2x naught plus a squared equal to x naught minus a squared. And just follow the mathematics. You will get that. You can pause the video now and follow the mathematics, but at the end, you will get that you need to satisfy this equation, this simple quadrature equation, which its solution is just minus b plus or minus p square minus 4ac over 2a, and a is this the coefficient of x squared, b is the coefficient of x naught, and c is the x to the power of 0 coefficient. Of course, this a is not this a. So let's verify whether both points are valid or not. And to verify this one, let's look to the field. We have the field equation E equal to Q. So let's make it just Q like this. 4 pi epsilon naught multiplied by R squared in the direction of A. So if we look to the first point here, if we go this direction is positive. The charge also is positive, yeah, plus Q here. Then the total value is positive. So we have here positive value in this direction for the first one. In the other direction, you have negative value. On the contrary, let's plot in the above here. In the contrary, if you look for Q2, you will have positive in this side because it is minus here, minus Q2. But it is negative in here. What we can understand is that the field is between minus A here in this region. Both of them are positive, so it is impossible for them to cancel. So this means that this value cannot be true. But either in here or here, it can be valid because one is positive and one is negative. And finally, since actually we don't have any valid points here based on the result which we have achieved, this means the point should lie in this side, which is this one. So this is just what I'm just trying to describe. This is x naught more than a. This is x naught less than a. This is the region. And finally, we conclude that x naught should be minus 5.8 to 8a. This is all for today. Thank you.